Introducing the Smart Vacuum Gauge, S-Gauge, SC-10. An entirely new concept vacuum gauge capable of simultaneous pressure and residual gas component monitoring. Simply measuring the vacuum level, or rather the total pressure, with a vacuum gauge doesn't reveal what is occurring inside the vacuum when the condition of the vacuum system deteriorates, or when the pressure doesn't drop. Is the problem caused by gas emission, leakage, etc., and where is the leak coming from? Using Vista Corporation's latest product, S-Gauge enables you to understand not only the total pressure vacuum level, but also the behavior of the different gas components and obtain more information about the condition of the vacuum system. For example, a large residual nitrogen gas component implies a possible air leak. Or, if there is a lot of water vapor, baking is required, or perhaps there is a leak in the cooling water line, etc. The S-Gauge weighs only 1.5 kilograms and is also compact in size. It can be operated from a Windows tablet, so you can carry it with you anywhere. Installing and operating the S-Gauge is extremely simple. Simply connect the S-Gauge to your vacuum system with an NW25 flange. Connect the USB cable to your PC and supply the power from the AC adapter provided. You are now ready to begin operation. Start your PC and launch the software. Measurement starts automatically, and the partial pressures of the gas components are displayed. Operation is also very simple. The full-range vacuum gauge incorporated in the S-Gauge measures the vacuum level from atmospheric pressure to ultra-high vacuum. The gas component measurement switches on automatically when the pressure reaches approximately 400 millitorr while pumping down from atmospheric pressure. Therefore, no operation is required. The gas component measurement automatically turns off to prevent damage if atmospheric pressure is suddenly restored during measurement. When the gas component measurement starts, the partial pressures of the gas components and the total pressure are graphically displayed on your computer screen. The graph is displayable as a bar or trend graph. The graph can be zoomed and slashed out, and the time axis is also scrollable in real time. The data is recordable by pressing the record button and can be saved as a CSV file for analyzing later. How does the S-Gauge determine the gas components? The S-Gauge distinguishes and measures the gas components from the difference in the electrical discharge color of the cooled cathode gauge, which is incorporated internally and used as part of the full-range vacuum gauge. The color of the electrical discharge differs according to gas type. Let's operate the S-Gauge and look at the actual electrical discharge inside. Start pumping down from atmospheric pressure. The total pressure measured by the full-range gauge is shown on the left. The electrical discharge starts automatically at about 400 millitorr. Nitrogen and oxygen are the main components during the initial evacuation, therefore the electrical discharge is a reddish color. As the pressure lowers, nitrogen and oxygen decrease, and, as the water vapor becomes the main component, the electrical discharge changes to a whitish color. The pressure has decreased to 10 to the -5 torr. Although the electrical discharge has weakened, it is still possible to measure low pressure using a high-sensitivity optical sensor. Let's look at the difference in the color of the electrical discharge by introducing different gases. From the left, nitrogen, oxygen, argon, helium, and water vapor. By displaying the wavelength spectra side by side, you can see the color differences are represented by characteristic wavelengths. The S-Gauge measures the light intensity at specific wavelengths for each gas component and displays their partial pressures. Let's look at how the S-Gauge is useful for monitoring the condition of a vacuum system. While monitoring the vacuum level only, or rather the pressure, with a vacuum gauge, the pressure stops decreasing midway. However, it is not known what has occurred. By monitoring the residual gas components using the S-Gauge, although water vapor is usually the main component at this midway stage, on this occasion, the situation has reversed as the nitrogen gas component becomes larger than the water vapor, and thereby restricts the pressure from decreasing. There seems to be an apparent leak somewhere in the system. Searching for signs of a leak by spraying argon, There appears to be a leak here because the argon level has increased, whereas nitrogen decreased. In this way, the S gauge can test leaks by using argon as well as helium. The leak is stopped. As the nitrogen, oxygen and argon decrease, the total pressure falls to 10 to the -6 torr. Now that water vapor has become the usual main component, we can improve the vacuum level by baking to purge the water vapor. Although it took about 30 minutes to notice the leak on this occasion, by closely monitoring the actual behavior of nitrogen gas with the S gauge, at about 5 minutes early into the pumping down stage, the decrease of nitrogen gas stopped. Therefore, we were able to discover that an abnormality had occurred. At this moment, valuable time can be saved by performing the leak test. By using the S gauge, it is possible to quickly discover any pumping down anomalies in vacuum systems and estimate their causes. It can also be used for leak testing. We looked at the overview and applications of the Smart Vacuum Gauge SC-10. In summarizing the features of the S gauge, the residual gas components and total pressure are displayed graphically on a computer screen. Therefore, system anomalies can be discovered quickly. No complicated adjustment or operation is required. Measurement of component gases automatically starts when they reach measurable pressure. Compact and lightweight, you can take it with you anywhere and perform measurement by simple installation. Because the S gauge operates from a low vacuum pressure of 400 millitorr, it is possible to measure residual gases when rough pumping, which was not possible before. The S gauge has no filament, which makes it tough and strongly resistant to contamination. If it does become contaminated, it is also easy to maintain and clean by the user. Vista Corporation believes the S gauge, which can measure total vacuum pressure and component gas partial pressures by a single unit, will be useful to everyone.